Hey guys, in today's video I'll be talking about the squeeze theorem, and if you do end up finding this video useful, please make sure to like and subscribe because it'll help me continue making videos. But anyways, let's begin. So what is the squeeze theorem? So if we're talking about the formal definition, it states that if f of x lies between two functions g of x and h of x, and the limits of both g of x and h of x at a point L are equal, then the limits of f of x at L is also equal. So, what does this even mean? So, let's create a line and we'll call it f of x. And then let's create another line and we'll call it g of x. So, you could see that g of x is always greater than or equal to f of x at all points in its domain. And similarly, let's create another line here and we'll call it h of x. And you could see that it's less than or equal to f of x at all points in its domain. And over here, you could see that they appear to be, the same. And we'll call this point L. So what squeeze theorem is saying basically is that if you take the limit of x approaches L of g of x, and it's equal to the limit of x approaches L of h of x, this must mean that it's also equal to the limit of x approaches L of f of x. And you can see this, you can see why this is true because f of x is bounded above by g of x and it's bounded below by h of x. So if those two limits are the same, then it must be that the limit of f of x will also be the same. So this can be useful in questions where if you try to take the limit, you might have like an indeterminate form or something like that. So you'll have to apply some new techniques to find its limit. And one of these techniques happens to be squeeze theorem. So now let's go into some practice problems. Okay, so this question is asking us to find the limit as x approaches infinity of 1 minus cos of x divided by x. So as you can see, if you plug in infinity, you'll get 1 minus cos of infinity divided by infinity. And how do you evaluate that? Well, you'll need to use squeeze theorem. So where do we even begin? So you could notice that, first of all, there is a cos of x. And what do we know of cos of x? You should know that it's bounded between -1 and 1. So any number you put in cos, it'll always be between these two numbers. And similarly, same applies to negative cos of x. And you could start to see that we're trying to make whatever is in here to be similar to what limit we need to find. So now you could see that if we just add 1 to both sides, we'll have 0 is less than or equal to 1 minus cos of x, and it's less than or equal to 2. And now what we could do is just divide the inequality by x, and we'll have this. And you could see we finally made it the same as what limit we need to find. And this just simplifies to 0 is less than or equal to 1 minus cos of x divided by x, which is less than or equal to 2 over x. And now we're ready to apply the squeeze theorem. So let's take the limit of all sides as x goes to infinity. So we'll have the limit as x approaches infinity of 0 is less than or equal to limit as x approaches infinity of 1 minus cos x divided by x, which is less than or equal to the limit as x approaches infinity of 2 over x. So you should note that the limit of a constant is just a constant, so we'll have 0. And we can't evaluate the middle yet, so we'll just leave it. So limit as x approaches infinity of 1 minus cos of x divided by x. And it's less than or equal to the limit as x approaches infinity of 2 over x. So over here, x is in the denominator and x is getting really big. So you're dividing 2 by a really big number, which means that it's just approaching 0. So you could see that the limit of in the middle here, it's less than or equal to 0, and it's also greater than or equal to 0. So this just means that it is equal to 0, so we have found the limit using squeeze theorem. Okay, so this question is asking us to find the limit as x approaches 3 of x minus 3 squared times sine of 1 over x minus 3. And immediately you could see that you can't just plug in 3 because over here you'll have 1 over 3 minus 3, which is equal to 1 over 0, and that is a division by 0, so we can't have that. So we'll need to use another method, and once again, that method is squeeze theorem. So you already know that the sine function is between -1 and 1, so it makes sense that any variation of the sine function, such as sine of 1 over x minus 3, is also between -1 and 1. So we could use that. And we're almost to finding our limit here. So again, just manipulate the inequality until you have your limit. So what we need to do now is multiply by x minus 3 squared. So we'll have negative x minus 3 squared is less than or equal to x minus 3 squared times sine of 1 over x minus 3 is less than or equal to x minus 3 squared. So over here, we could see that these are now matching, so we can apply the squeeze theorem. So let's start by taking the limit as x approaches 3 of the inequality. So limit as x approaches 3 of negative x minus 3 squared is less than or equal to the limit as x approaches 3 of x minus 3 squared sine 1 over x minus 3 is less than or equal to the limit as x approaches 3 of x minus 3 squared. So over here, you can see, you could just plug in 3 and there's no problem with that. So we'll have -0, which is just 0. So I shouldn't put the negative, I mean, it's the same thing. But anyways, is less than or equal to the limit as x approaches 3 of x minus 3 squared times sine of 1 over x minus 3, and it's less than or equal to. Similarly, when we evaluate this limit here, we'll just get 0. So we could see that this limit here is less than or equal to 0 and greater than or equal to 0. So by the squeeze theorem, this limit is equal to 0. So yeah, that's the video. If you found it useful, please make sure to like and subscribe, and thank you so much for watching.